Then let's get started today then. We'll start with the definition of amplitude. Amplitude is going to be half the distance between the minimum and maximum values. So remember when we graphed yesterday, we sketched our graph yesterday, we saw the function from 0 to 360 degrees. And it made that wave where it had a maximum and a minimum. So half the distance between that max and min would be your amplitude. Okay. Periodic, that means the function repeats itself. Alright, so periodic means it's going to do something and it's going to do it again and again and again. Alright. Alright. A cycle, that's one, let's see, what's the best way to describe it? A cycle is looking at the function before it repeats itself. Before it starts a new cycle, I guess. So we can see, like from peak to peak maybe. That'd be a good way to describe a cycle. That's also how we could describe one period of the function. Okay, it's just basically it's one cycle before the function repeats. Let's see. Yeah, one period is one cycle of the function. We can sketch a little drawing here. So typically, when you have your sine function, it's going to start at 0, it's going to go up to a maximum, down to a minimum, back to 0, and then it's going to start again, and it's going to do the same thing again. So right here, this box right here, when it starts over again, that's one period of the function, or one cycle. So our goal today is we're going to try and sketch one period of the function. That's what we're trying to do. Okay. So first thing, when the last time we dealt with degrees, going up from 0 to 360 degrees, today we're going to be dealing with radians exclusively. So we're going to convert every 15 degrees into radians, but we can start with like 0. 0 degrees is the same as 0 radians. And then go to the very end. I know 360 degrees is the same as 2 pi radians. And one way I can find all the radian measures is I can take every single degree measure and do times pi over 180. But that would take a really long time. Another way to think about it is radians are just fractions, but they just have a pi attached at the end of them. So I try and ignore the pi and think about just basically we're going from 0 to 2, right? So 0 to 360, and we're going 0 to 2. And then half of 360 is 180. Half of 2 is 1. So this would be 1 times pi. That's what 1 radian would look like there. Half of 180 is is 90. Half of 1 is 1/2. So this is 1/2 pi, or pi over 2. That's kind of how we would figure it out. And then you can think about counting as well. So we can count 0, 90, 180, 270, 360. Counting by 90 degrees. That's also counting by 1/2. So we have 0 halves, 1/2, or 1 pi over 2. And then 2 halves is 180. 3 halves is 270. And 4 halves is 360. That's kind of how we can fill in this table, is thinking about fractions and counting. Two ways to think about it. If I take 1 pi and I say, let's find 1/3 of that, that would be 60 degrees. 1/3 of 180 is 60, so that's going to be pi over 3. And then I can count by 60s. 1/3, 2/3, 3/3 is just 1, so that's why it's pi. 4/3 is when I get to 240, and then 300 degrees would be 5/3. So again, I'm counting by thirds. 360 is 6/3. And the pi just kind of goes along for the ride. There's just going to be a pi in every one of these. It's coming along for the ride, but I'm really just counting by fractions here. That's the idea. So I counted by, I went from 0 to 360, then I counted by 180s, so I did 1 pi, 2 pi. Then I counted by 90s, 1/2 pi, 2/2 pi, 3/2 pi, 4/2 pi. Then I counted by 60s, 1/3 pi, 2/3 pi, 3/3 pi, 4/3 pi, 5/3 pi, 6/3 pi, etc., etc. Now I can try and count by 30s. Half of 1/3 is 1/6. So I could count by 30s, and I can say, which is going to be every other box. 1/6, 2/6, 3/6, 4/6, 5/6. That one's not filled in yet, so we'll fill it in. The other ones are all just simplified. 2/6 is 1/3. 3/6 is 1/2. 4/6 is 2/3. And then 5/6, 6/6, 7/6, 8/6 is filled in, 9/6 is filled in, 10/6 is filled in, 11/6 is not filled in, and then 12/6 is 2 pi. Again, I'm just using my knowledge of fractions and counting to fill in the table. Very last one here, 15 degrees. And I go ahead and say, what's half of 1/6? That's going to be 1/12. And that means every single box I can count by 12s. So I can say 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12, 7 pi over 12. Actually, before I do the pi over 12s, thinking about it, because if I do 45, that's 3 pi over 12. That actually simplifies. That's actually 1 pi over 4. So I could count by 45s first before I count the 15s. And I'll do that. 45 is 1/4, 2/4 is 90, 3/4 is 135. Oops. 4/4 is 180. 5/4 is 225, 5 pi over 4. 6/4 is 270. 7/4 is 315, and 8/4 is 2 pi. Perfect. Now, finally, sorry, we'll count by 12s. And I caught that because when I got to 3 pi over 12, I knew that simplified, so it didn't sound quite right. So there's 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, and we just count by 12ths all the way across until we get to 360 degrees. And that's how we'll fill in the rest of our radian measures here. 8, 9, 10, 11 twelfths, 12 twelfths, 13 twelfths, 14, 15, 16, 17 twelfths, 18, 19 twelfths, 20 twelfths, 21 twelfths, 22 twelfths, 23 twelfths, and I'm just putting pi at the end of each of these, and then 24 twelfths is 2 pi. That's how I can fill in this entire table for radians. And this is a good table to have because now I've got conversion factors done for every 15 degree values up to 360 degrees in terms of radians. And I'm going to need to use radians for these graphing problems today, so it's important to know that information. All right. Any questions on that part when we were counting and doing all that stuff? Anyone need a little more time to see it before I move on? Okay, moving on then. So then we have the domain of each function, and we're talking about specifically the parent functions right now, y equals sine of x, y equals cosine of x. So y equals sine of x, we already did a little sketch of that. I'll show you on Desmos in a little bit too. But technically, it goes on forever. We put arrows on it yesterday saying that it goes on forever in both directions. So the domain is all real numbers, which is going to look like this. It's going to get capital R with an extra line through it. It stands for all reals. And then the range of each function is going to be, in these parent functions, -1 is less than or equal to y is less than or equal to 1. That's the range of each function. Just saying that it's never going to go below -1 or above 1, for the parent functions at least. When we start dealing with transformations, we'll see that the range will change. Okay? But for right now, the parent function's -1 to 1. The maximum value of each function, that's 1. It's going to be represented by capital M, and it's just 1. That's the top of the range. And the minimum value is going to be represented by lowercase m, and that's -1. And then the amplitude of each function, which we mentioned up above, that's going to be half of the max minus the min, the distance between the min and the max. In this case, it's 1 minus -1, which is really like 1/2 times 2. So the amplitude of the parent functions is just 1. That's half the distance, because the distance from 1 to -1 is 2. Half that distance would be 1, and that's what your amplitude is. Okay. Each of these functions is periodic, meaning they're both going to be cyclical. They're going to complete a cycle, and then they're going to start their next cycle. They're going to complete a period, and then they're going to start their next period. All right, it's just going to keep going over and over again, infinitely in both directions. Okay. And then last couple things to talk about. X-intercepts for y equals sine of x. The first x-intercept is going to be at 0. We talked about the point 0, 0, and then it goes up to max, comes back down, and then it hits 0 again, and it hits 0 again at pi. And it would happen in both directions. It's going to be at positive and negative pi. And then it hits again at 2 pi. It hits again at 3 pi, and 4 pi, and 5 pi, and 6 pi, and k times pi, as long as k is an integer value. And an integer value is like this, is like a z, but with an extra line. So every pi, there's going to be an x-intercept in both directions from 0. A distance of pi apart for the sine of x function. For cosine of x, it's actually very similar, except it started at a maximum and then it works its way down to 0. And it's still going to be every pi apart, but the difference is it's going to be on the fractions 1/2, 2, 3/2, 5/2, 7/2, until eventually we get positive or negative k pi over 2. And again, where k is an integer value. So cosine, just like sine, is going to repeat every pi. There's going to be another intercept. But on cosine, it's just going to be on the fractions instead of the whole numbers. Okay, there's still pi units apart though between intercepts. The intercept for y equals sine of x, the y-intercept is y equals 0. And the y-intercept for y equals cosine of x is y equals 1. So if I plugged in 0 for sine and typed it into my calculator, I'd get 0. If I plugged in 0 for cosine, I'd get 1. All right. So those are the two intercepts, the two y-intercepts. All right, and the two things we're really going to focus on today, we're going to start talking about the 5 key points and then 2 types of transformations that we'll see today. The first one is the vertical stretch. The vertical stretch is always going to be a reference to a change in the amplitude of the function. And a horizontal stretch is going to be a change in the period of the function. And what we're going to be doing here is we have y equals a times sine bx. The amplitude is going to be represented by that a value. Or y equals a times cosine bx. And again, that a value out in front of the sine or cosine function respectively is the amplitude. So we can write down amplitude as the absolute value of a. Amplitude will always be a positive value. So we'll write that down. Amplitude is always a positive number. The period, on the other hand, is typically, of the parent function, is 2 pi. So the way it works with the b value is we take whatever the b value is and we say 2 pi divided by that b value is going to give us the period of the function. And that's exactly what this part says down here, where we say the 5 key points. Each graph has 5 key values on the x interval, and it's going to be between the start of the period at 0 and the end of the period, 2 pi, divided by whatever the b value is. Okay. Now, what we're going to be doing is we're going to be looking for 5 key points here. And when we're looking for 5 key points, we'll see the intercepts will be some of those key points. And on this sine function, we can see there are 3 intercepts. And those intercepts happen at 0, 0, and then halfway through the function, so half of whatever 2 pi over b is, and then at 2 pi over b. So there's 3 intercepts on the sine function. That's 3 of our 5 points. Then we're going to need to identify the maximum value. And that's going to be wherever it hits the peak. And then finally identify the minimum value, and that's going to be the trough. And notice there's 1 maximum, 1 minimum, 3 intercepts, that's 5 points. Very similarly, the cosine function is going to have 5 points, but slightly different. It's only going to have 2 intercepts. But it makes up for that because it's going to have 2 maximum values, because it peaks at the start of the period and it peaks at the end of the period. And then finally, it has 1 minimum value, but that makes up the 5 key points for a cosine function. Right, and we'll take a look at one of each of those here. So what the goal today is, I'm going to switch to Desmos here for a second. First thing I want to do, identify my amplitude. Amplitude's always going to be whatever the absolute value of the A value is. So in this case, blue, the amplitude is going to be 4. Remember, it's always positive, so it's 4. On the second problem, the amplitude, there's no number in front of the cosine, so we can assume it's a 1, so the amplitude is 1. And then B value, whatever number is next to the x inside the parentheses, or in this case there aren't any parentheses, but just after the cosine or sine. In the first one, it's 1, so this would be 2 pi divided by 1, so the period's just 2 pi. In the second one, it's 4, so I do 2 pi divided by 4, and 2/4 is the same as 1/2, which is why we end up with pi over 2, which makes sense, because when I was on Desmos, I shortened my period from 0 to pi over 2. I could tell by looking at it, but that's also the case. Because this is a sine function, first thing I want to do is sketch a sine function. Starts at 0, goes to the maximum, back to 0, down to the minimum, back to 0. Without putting my viewing window on there at all, or my labeling my axes yet, I'm just going to sketch that sine function. Cosine function, same thing. Starts at a maximum, goes down to 0, then a minimum, and then back up to its maximum. And I'm going to go ahead and sketch my cosine function. Make some nice smooth curves, put arrows on it. There's my cosine function. So first thing you're going to do on all of your homework problems today, problems 4 through 9, just go ahead and sketch it. Hey, that's a sine, I'm going to sketch this top line. Hey, that's a cosine, I'm going to sketch this bottom line. And now, after that, I can identify the amplitude, the period, label it, and then I can write down my 5 key points. So for example A, we know that it had a period of 2 pi because we just solved for it. So this is going to end at 2 pi. Example B had a period of pi over 2. All right. And then whatever the point is in the middle, that's exactly the halfway point. So what's half of 2 pi or half of 2? 1. And then the bottom one's 1/2. So what's half of 1/2? That's 1/4. And then over here, this is technically 1/4 of whatever the ending point is, or half of a half. Half of 1 is 1/2, so that's going to be pi over 2. Half of 1/4 is 1/8, so that's going to be pi over 8. And because it's broken down into fourths, I could technically count by whatever this fraction is right here. And I can count all of them. So starting with 1/2, I can say 1/2, 2/2, 3/2, 4/2, and that gets me to the end. On this one, I can say 1/8, 2/8, 3/8, 4/8. So if I can find that very first point, I can count by that fraction all the way across to get all of my points. Okay. 1/8, 2/8, 3/8, 4/8. That's how this works in the simplest form. Now the y-axis is representing our amplitude. So in this case, our amplitude is 4, so this goes from 4 to -4. In part B, our amplitude is 1, so it goes from 1 to -1. So in the first one, our amplitude changed. In the second problem, our period changed. But the graphs look exactly like the parent functions. They look exactly the same, but we just changed the viewing window or the axes around them. Now I can go ahead and label my intercepts. So I had a 0, 0. That was one of my intercepts. I had a pi, 0. And I had a 2 pi, 0 here. So there's 3 points out of my 5. On this other one, I had pi over 8, 0. That's an intercept. And I had 3 pi over 8, 0. Those are 2 of my intercepts. Maximum values, up here I had a pi over 2, 4. Down here, there were two maximum values. One of them was 0, 1, and one of them was pi over 2, 1. And then finally, last but not least, minimum values. On the first graph, it was 3 pi over 2, negative 4. On the second graph, the minimum value was pi over 4, negative 1. And that's where my minimum values come from. So that's how we get the 5 key points here. And remember that, like, we're thinking about circles here. So the parent functions, one full circle is 360 degrees, or one full circle is 2 pi radians. So that's why we always start with a period of 2 pi, and we take whatever the b value is and divide 2 pi by the b value to get our final period. And that's why the first one starts with a period of 2 pi. Second one, the b value is 4, so we did 2 pi divided by 4, and we got a pi over 2. That's how we got the period for the second one. Okay, so now on your assignment tonight, what you're going to be asked to do, the first 3 problems, identify the amplitude and period just by looking at the graphs. So can you identify the a value and then the period of the function? And then problems 4 through 9, like I said, what I want you to do absolutely first, identify, is it sine or is it cosine, and then sketch it before you do anything else. Now, after you have the sketch, identify the amplitude and the period, and then label your graph, and finally fill in the intercepts, maximum, minimum values. That's the order you should kind of work in for problems 4 through 9. Just 5 practice problems, or I guess 6 practice problems to get you to practice sketching these functions. All right, we've got 30 minutes left, so that's more than enough time, honestly, for you guys to finish this before your 3-day weekend even starts. So I recommend strongly that you work on this right now. If you stay on the Zoom call, I'm more than happy to answer your questions or do an example with you if you're still a little confused. Otherwise, have a great weekend. Thanks so much, you guys.